In the first lecture, we are going to introduce and define the differential equation and the solution of the differential equation, what I mean by solution of differential equation. Also, we are going to learn the concept of initial value problems. And those two covered section 1.1 and 1.2 from your textbook. Now, here's the objectives of our lecture. Actually, I believe it's very important to read those objectives by the end of this lecture, to know that you understand all those concepts, okay? Now, let me, before go through the differential equation, ask you a small question. What I mean by equation? So do you remember what is the meaning of the word equation? Or what you can understand from the word equation? Can anyone of you remember? What I mean by equation, yes.
An expression that equals another expression.
Yes, you are right, Islam. So I have two expressions. Those two expressions must be equal. So it is a mathematical statement which contain the sign equal. Okay, like maybe x squared plus 2x equals 7. So this is an equation with the unknown variable x, okay? And this is the right-hand side, and this is the left-hand side, and this the equity is signed between two terms. The most important thing here in any equation, you should see this equal, okay? By the way, this equation is second order, so it isn't linear because I have x squared. The linear equation, that means you have only x. Also, I can say that sine x equal x. Also, this is an equation. And the variable here, or independent variable or unknown, it is x. Also, maybe if you have x plus 1 equal 4, also this an equation. But this equation is linear equation. This one isn't linear. And the equation which contains sine x also isn't linear because I have the function sine. So starting from now, you can determine if the equation is linear or non-linear depending on the power of x and the functions or the terms in your equation. If you have sine, len, exponential, tan, those terms are non-linear. But the linear, that means I have only x to the power 1. This is for algebraic equation. Let me now go to the differential equation. So the differential equation, first of all, I understand what is the meaning of equation. Let me move to the word differential. All of you must know that the word differential comes from the differentiation, which is the derivative. So now differential equation means equation which contain some derivatives of my unknown function. So if my unknown function y, and I need an equation which contain the derivative of this function with itself, maybe I will call this differential equation. So like this one, maybe. Do you remember the notation of the differentiation? The notation of derivative?
Like dy by dx?
Yes, dy by dx
dash.
or the dash or prime, we call it a prime. So y prime maybe plus y double prime maybe plus x equal y. So this equation, notice here Islam said that y prime, it is the first derivative of y with respect to x. So it is dy over dx. I call it a prime or dash, you are free. Now this equation, because I have here equal, this equation is differential equation. I called it differential equation because it's contained the derivative of the unknown function. And here the differentiation with respect to x, so I will call x the independent variable. Independent variable. So starting from now, differential equation, that means I have an equation with the function y with its derivatives. First derivative, second derivative, third derivative, and so on. Okay? Now, third derivative, y3 primes, can be written like d cubed y over dx to the power 3. Now, what about y to the power 4? Also, it's the fourth derivative. Actually, look now, if I wrote four primes or four dashes, it isn't easy to write them. So instead of 4 primes or 4 dash or the fourth derivative, I'm going to write like this: y to the power 4 between brackets. So if you write the power between brackets, that means it's the order of the differentiation or the number of primes. So y to the power 5 between brackets, that means you have y with 5 primes. Okay, the fifth derivative. So now I think that the concept of differential equation is clear. Let me check or study with you the order of differential equation. So if I need to study the order of differential equation, now look to this equation here, which I wrote this one. Let me with you discuss this equation, the first one here. If I need to check the order or to find the order of this differential equation, I'm looking for the highest derivative. So here, this one is the highest derivative. So the order of this differential equation is the order of the highest derivative, which is 2. What about of the following equation? What do you think about this equation? The order of this differential equation. You have to search for the highest derivative. Here I have 3 dashes, but here you have fourth derivative, 4 primes. So the order of this differential equation is 4. Okay? Is it clear what I mean by the order of differential equation?
Yes.
Yeah. So now also here I have this differential equation. Notice now in this example, my unknown function, it is x and the independent variable is t. No problem for me at all. Now this equation of second order because the highest derivative is 2. Okay. So sometimes my unknown function is y and the variable or independent variable x. But also in another time, maybe my unknown function is y and the independent variable is t. Okay? And at that time, you will write is y dot. So starting from now, the derivative with respect to t, which is the time, can be written as y dot instead of y prime. So if you see y dot, that means it's the derivative with respect to time. But usually, if you see y prime, that means the derivative with respect to x. Okay? Now, I'm going to introduce the difference between ordinary differential equation and partial differential equation. Notice now, in our course, we are going to study only ordinary differential equation. And we aren't at all go through the partial differential equation. I think you studied the partial derivative in calculus 3, but for me, the partial differential equation isn't in my course. So I'm going to focus only on the ordinary differential equation. Let me introduce the difference between them. Now, ordinary differential equation, that means you have only one independent variable. Only one independent variable. So look to this equation. Here my unknown function is y and the independent variable is x. So this an ordinary differential equation. And notice that the notation for the derivative, it's d by d. Also look to this equation. Here, yes, you can find 2 unknowns function, but only one independent variable, it is t. So this also an ordinary. Focus to the partial differential equation. First of all, look to the notation for the partial derivative. And here you have this variable and this variable. So I have 2 variables. Also in this equation, 2 variables. Also in this equation, partial t and partial x, 2 variables. I'm not going to study the partial differential equation at all. Only what I need, the ordinary differential equation in my course. So don't care about the partial partial differential equation. Okay. Now let me introduce the difference between linear and non-linear of differential equation. But before that, let me give you an example of algebraic equation, and let us together discuss if it is linear or non-linear. What about of this equation? X plus 7 equal 1. What do you think about this equation? Linear or non-linear? Do you know what is the difference? Linear, because it contains only x, no x squared. What do you think about this? 7x plus 1 over x equal 11. What do you think about this equation?
Non-linear.
Non-linear. David is speaking. Yes, David said non-linear.
Yes.
Would you please, Dave, explain why it isn't non-linear? I see here x and I see here x. So no x squared. Why you said it is non-linear? By the way, you are right. But I need to be sure that all the students know why it is non-linear.
عشان 1 over x دي مش linear function.
Yes, you are right. This one can be written as x to the power -1. So now my power isn't 1, so it isn't linear equation. You are right. Also, look to this equation, which I wrote before, sine x equal x. This equation also isn't linear because it's contained the sine. Also, tan x equal maybe x plus 1 isn't linear because it's contained tan x. So all the functions like exponential, ln, fraction, or sine, all those aren't linear. The linear only with x to the power 1. Okay, this for algebraic equation. Now let us move to differential equation. By the way, the students can determine if the differential equation linear or non-linear by looking for the variable, for the unknown function. And if the unknown function with its derivative has only power 1, so the equation is linear. But if one of my function or its derivatives has power more than 1 or have the function sine or cosine, so the equation isn't linear. And another method to determine if the equation is linear or non-linear is to compare it with the following equation. Notice here in this formula, this formula is the general form for the linear differential equation. Look here how I can study this form. Here I have a n x, any function of x, so contain only x, times the nth derivative of y. Notice here the power of the nth derivative is 1 because I have derivative of order n, but the power is 1, plus function times n minus 1 derivative, and so on. Also function of x, notice here this function with respect to x only. Okay, and here the first derivative with power 1, also a function times y with power 1 equal function with respect to x also. So any equation which can be written similar to this can be considered as linear differential equation. Let me check the following examples. The first equation here. Let me compare, first of all, let me compare it with the general form. The gx, it is cosine x. Y similar to y. A0x, it's 5. Y prime, y prime is similar to the first derivative. -4x, it is a1x. And y double prime, also here I have, and this is the coefficients. Now, this equation is similar to this because all the coefficients here contain only x, no y. And the y with its derivative with power 1, so I can say it is linear with respect to my unknown function y. Okay, because no y squared, no y prime squared or cubed, and so on. Now, the order of this differential equation is 2. I think the order of the differential equation is very easy. Let me move to equation number 2. Can anyone of you now? Actually, for me, usually I choose the students by their names to answer the questions. But today, because it's the first lecture, so you are free. If you have or if you know the answer, please try to answer. So this equation number 2, I need to know if it is linear or non-linear. What do you think?
Non-linear.
Non-linear. Who is speaking?
Arwa.
Arwa? Yes,
Yeah.
Arwa. Why it is non-linear, Arwa?
عشان it's not to the power of 1. Y is not to the power of 1.
Why? Why? You said why?
Y is not to the power of 1.
Here? This
لأ
one?
لأ في الترم اللي قبله.
Yes. So the derivative of y with power 4 isn't with power 1. So this equation is non-linear. You are right. So let me write here. This one is non-linear. But this one is linear. Actually, some students will ask, Doctor, let me go back to question number 1. Here I see cosine. And you told us that if you have cosine, so it is non-linear. Yeah, look here. If you have cosine of your unknown function, so it will be non-linear. But if you have cosine for the variable, don't care about this. Okay? The most important thing is your unknown function. So question number 2, it is non-linear because the first derivative with power 4. Yeah, Arwa, only last question. The order of this equation is what? Equation number 3.
مش عارفة بس is it 3 ولا 4؟
Yeah, it is 3. The order is the highest derivative. So here you have first derivative, but here you have third derivative. And the order is the highest derivative. So the order of this equation is 3. Okay? Thank you, Arun. Now let us move to equation number 3. What do you think? Anyone of you? What do you think about equation 3? Linear or non-linear? Can anyone help? Equation linear. Muhammad said linear. Yeah. What do you think, Muhammad, about y to the power 4 between brackets? This one linear?
It's the fourth derivative.
It's the fourth derivative. So this equation also linear because all y and the y with derivative with power 1. So this equation is linear. What about the order of this differential equation?
4.
4, because the highest derivative, which is this one, is 4. Okay? Last equation. Now, who can help to check the linearity of last equation, linear or non-linear?
I think
What do
it's
you think?
linear.
Linear. Who is speaking?
Yusuf.
Yusuf. You found it to be linear. Other students, what do you think? Here, notice, Yusuf, that your unknown function is u. Okay, and independent variable is r. Other students.
Yeah, non-linear عشان الكوساين يو.
Non-linear, yes. Muhammad Yasser is speaking. Yeah. So here, notice now I have cosine, similar to this. But here, in my cosine, I have the independent variable. Unfortunately here, inside my cosine, I have the unknown function. So if the unknown function is inside cosine, so it is non-linear. Okay? And the order of this differential equation is 2 because the highest derivative is 2. Is it clear now what I mean by linear and non-linear?
Doctor,
Yeah.
I don't understand in number 3, why is it linear?
Yes. So now let us together, Muhammad, discuss why do you want it to be non-linear? Why do you think it is non-linear?
Because the y has the fourth derivative.
Yeah, if the y, look, I can say it is non-linear if the y or its derivative with power more than 1. So if you have here y to the power 4, it is non-linear. If you have here y second derivative with power 3, so also it is non-linear, okay? Here, for this one, if you have the fourth derivative with power maybe 11, so you can say it is non-linear. But now, for this form, equation number 3, I have y with power 1. I have y double prime with power 1. I have the fourth derivative. Also, the power of y to fourth derivative is only 1. All my y with its derivative has the power to be 1, so it is linear. What do you think, Muhammad?
Okay, thank you, Doctor.
Welcome. Other questions? Or can I move to the second slide? So let me, yeah. Now I'm going to introduce some specific forms for the differential equation. Don't forget differential equation, that means you have equation with the unknown function with its derivative. If all the terms of your equation in the left-hand side, I'm going to call this form of the differential equation general form. So I'll give you an example. You will find it's very easy. Maybe y3 primes plus x y double prime minus x squared y prime equal, yes, just a minute, I need to write here, plus x equal 0. So this is the general form because all my terms in the left-hand side. But if it is plus equal 10, I'm sorry, if it is equal 10, this differential equation isn't in general form. How to write it in the general form? What do you think?
-10 equals 0.
-10, so move 10 equals 0. So it's very easy, this form. Now I have second form, which I call it normal form. What I mean by normal form, you have to write the highest derivative in the left-hand side and all the rest terms in the right-hand side. I will repeat, the highest derivative alone in the left-hand side and all the rest terms in the right-hand side. Can I write this equation in the normal form? Yes, Professor. Leave the highest derivative in the left, so it is y3 primes, and move all the terms to the right-hand side, so equal negative x y double prime plus x squared y prime minus x plus 10. So I think it's very easy to go from form to another form. Okay? Any question about this idea? Can I move?
Yes.
Yeah. So now let us speak about first order differential equation. Professor, what do you mean by first order differential equation? That means you have only y prime, no y double prime, no y3 primes, only y prime, first derivative. Okay? And what I mean by second order differential equation, that means you have y prime and y double prime. Okay? So you must see y 2 primes to say it is second order differential equation. Now in this slide, let us focus in the first order differential equation. And let me introduce 3 forms of the first order differential equation. First form, the general, as we said in the previous slide, general form, that means all terms in the left-hand side, like this one, like this equation. Let me give you a specific example, maybe y prime plus xy minus 10 equals 0. So this is first order differential equation in the general form. Now let me introduce also the normal form. The normal form, that means you need the first derivative, which is the highest one now, in the left-hand side, and move all terms to the right-hand side. So you have to write in this formula, y prime equal negative xy plus 10. Also, the normal form is easy. Now, the new form for first-order differential equation, which we call it differential form, is very important. Differential form. This is the differential form. Function times dx plus also function times dy equals 0. And it is very easy also. It's very easy to go from this form to this or from this to this. Let me together with you go from this to this. How I can go from this form into differential form? What do you think? If I have this form and I need to go to this, what should I do? Don't forget that y prime is what? Y prime is what? Dy by dx, you are right. Equal the function f. By the way, the function f, maybe it is x itself. Maybe it is x divided x plus 1. Maybe it is sine divided cosine. I don't know. Yeah. Now I need to go from this to this. What should I do? What do you think? Here the f has denominator to be 1. Okay? Can I do cross product? If I did cross product, so what I have now, dy times 1, dy times 1 equal f times dx. Move all of them, maybe, move all of them here. So you have f dx minus 1 times dy equals 0. Now, can I say this similar to this? Yes, doctor, it's very similar. What do you think about your m now? Your m, which is the coefficient of dx, it's f. And what do you think about your n, which is the coefficient of dy? It is negative 1. So it's very easy to go from one form to other, okay? By writing the y prime alone or by writing y prime to be dy over dx, okay? Is it clear? So I'm going to move to second slide. Now let me give you some motivating examples. And actually, here in differential equation, not only you need to solve problems from my mind. No, actually, you need to solve some or to model some real life phenomena as a differential equation. So maybe after 3 lectures, I will describe some phenomena in some sentences, and you need to model it or to write it or to express it as a differential equation. Then you need to solve it, okay? Now let me first of all give you the simple example here. I have this differential equation and I need you to guess one or all possible solution for this differential equation. Before we go through this one, let me ask you about the solution of the following equation. So if you have x plus 1 equal 4, can you guess the solution of this equation? Can you guess? 3. X equals 3. So sometimes solving the equation by guessing is very easy. What do you think about this equation? X cubed plus x squared minus 2x plus 1 equals 0. How to solve this one? Maybe you need a calculator to find the solution of this. It isn't easy, okay? But this one, it's easy. Also for the differential equation, some of them is very easy. You can guess the solution. And the solution will be a function which satisfy the differential equation. Like here, you told me it's a 3 because if I plug in here 3, it will be 3 plus 1, which is 4, which is an identity. 4 equal 4. It's an identity or satisfy always. So this is the solution. Now, for this differential equation, and by the way, the guessing isn't my aim. Only now, because I didn't teach you how to find the solution. By the way, we have specific techniques to solve more than maybe 10 kinds of differential equations. but I'm not going to study them in this lecture. In the coming one, maybe I will start. Now, by guessing, can any one of you guess the solution for this differential equation? It's a differential equation, which is first order because I have the first derivative only, and I need to guess one solution.
I think it can be 10 dy dt equals y.
Could you please repeat?
I think it's gonna be, I don't know, but I think it's 10
Yes.
dy dt equals
D-
y.
dy dt equal y? No, look. Here, this is a differential equation because it's contained this equality, okay? And differential because it's contained the first derivative. My unknown function is y, and the independent variable is t. And when I ask you find or guess solution for this differential equation, that means I need you to guess y as a function such that if I plug in here, I will get an identity. So when I ask you to guess, you need to tell me, Professor, maybe y equal something in terms of t. Okay? So can any one of you guess y equals something of t such that satisfy this equation?
Integration of 0.1y dt.
Repeat, David, repeat.
Integration of 0.1y dt.
Yes, you are right, but actually I don't know the integration. You have, look, David, I need you to tell me. Yes, I understand, but I don't, yes, you told me that dy or integration of 0.1, I'm sorry, let me write it correctly. Integration of 0.1 y dt. But for me, as a professor, I don't know this integration because I don't know why. So I need you to tell me or to give me y equal something of t, only t. Now you give me your y is something, but inside your thing you have y. I need something without y, with only t. By the way, it's very easy. It's a simple function. Let me give you a simple equation. If you have y prime equal y. Now, can anyone of you guess the value of y? You can read this equation. The first derivative of my function y is itself my function.
E power x.
E power x, yes. So here, y e to the power t. You are right. Or to the x. Don't care about the variable. Now, can you give me the solution of this? This one, it's easy. And this one also similar to this. Only you need to multiply. So your y equal e to the 0.1 t. Let me check if this one is right or wrong. Let me find the first derivative by prime equal. I need to find the derivative of the exponential function, and the rule said find the derivative of the power and multiply it by the same function. Derivative of the power, which is 0.1, I'm going to multiply it by the same function, which is e to the 0.1 t. So this function is the solution for this differential equation. Okay. Now, let me check if really it's solution or no. Instead of this y prime, I'm going to write this. So 0.1 times e to the 0.1 t equal 0.1 times y. What is my y? This is my y, which is e to the 0.1 t. So this the same to this. So this one is solution. But he wrote here all possible solution. What do you think if I multiplied here by c? C is constant. You can choose the c to be 1. I can choose it to be 3. Your colleague will choose it to be -4. So this c can be take any value. Let me check if this one, which I can call it family of solution. Why I call it family? Because the c it's a constant. I can take more than one value. Okay. Now the derivative of this function, I will leave c because c is constant. Plug in here the c and 0.1 as it is, and instead of y, I'm going to write c times. So also this one is satisfied. Okay, so the solution for this differential equation, all the solutions is written in this formula. Professor, I think for me, because as a student, I forget the differentiation rules. So what should I do? Actually, we are going to learn specific methods to solve like this differential equation. But today, only by guessing, to do some refresh about the differentiation, okay? Any question about this idea? So now I have a question. Where does this differential equation come from? That means this equation comes from my mind, from the mind of mathematicians, or from some real life phenomena. Actually, this differential equation can describe more than one phenomena in our real life problem. Like the first one, if you have an account in a bank and you deposit some money, okay? So the rate of change or the change of your money in a specific time will depend or will depend on the interest rate. Look to the 0.10%, which is 0.1, will be the continuous interest of your bank times the amount of your bank. So this differential equation describe the change of the amount in the bank. If you have an account and you deposit some money in a specific years, okay? Also the same equation, like this one, can describe the population or the rate of change of the number of bacteria or virus in some years, when 0.1 is the growth rate. And by the way, COVID-19 or coronavirus can be described not only in one single differential equation, but now you can find more than 10 systems of differential equations which describe this population of coronavirus. And actually solving those systems is very difficult. So usually we try to solve it or them numerically. And by the way, now I'm trying to write a research paper how to solve some specific systems which describe COVID-19 using numerical approximations technique. Okay, so here the idea which I need to understand those differential equations which we are going to study not from the mind, those describe some real life phenomena. Okay, let me do something in the equation by adding the term 5,000. So the same equation, but I add 5,000. Also, this equation will describe the rate of change of your money in the bank, but with depositing here, you try to deposit, always you try to deposit a specific amount of money, which is 5,000 in a year or in a month. That depend in the unit which you try to study your problem. Okay, so this problem also, this equation describes the rate of change of your amount of the money in your account, but here you have continuous deposit stream equal to 5,000. Let us move to the second example. Look to this equation. It's a differential equation with the unknown variable x and independent variable t. And together, let us try to guess the solution of this equation. What I mean by this equation, second derivative of my equation, second derivative of my unknown function plus my function is 0. That means second derivative of my function is equal to negative of my function. Can I say like this? So this equation can be written x double prime equal negative x. So second derivative of my unknown function is negative to my function. Can anyone guess the x now is what? Such that if you differentiate it twice, you will get negative of the given function.
Sine.
Sine. Great.
Cosine.
Sine and cosine. Great. Muhammad, Arabi, and who said cosine?
Me.
Ahmed Khalil. Great. So I can choose my x to be sine, and I can choose my x to be, I'm sorry, sine t. And my x maybe also can be x equal cosine t. But let me check, okay? If x is sine, so x prime, it is cosine, it's very easy. And x double prime now, x double prime, it's negative. Okay, negative sign. Let me plug in my equation here. Instead of second derivative, I have negative sign. Plus my function now, it is sine. Plus sine. T equals 0. So 0 equals 0, satisfy. So this is one solution. Let me check second one. Let me check second one and let me use the red now. So x prime, derivative of cosine, it is negative sine. And second derivative will be negative cosine. Let me plug in here in the given equation and I will check if it's satisfied or no. So second derivative, it is negative cosine plus my x now in second case, it is cosine equals 0. So 0 equals 0 satisfies. So also this is solution. So I found two solutions. He need us to guess all possible solution. What do you think to guess all the solution? What should I do? What should I
Positive
do?
or negative.
Yes, you are right. Positive or negative sign. Great. Also, more than this.
ما نحط C variable كده جنب sine
Yes, you
cosine.
are right. Constant. See as a constant. So I can choose my x now in general case. Look, I'm going to write here. Let me use the green. X equal C1 cosine t plus C2 sine t. Now, if I differentiate this twice and plug in here, you will get 0 equals 0. Because C1 and C2, those are constants. Maybe you will choose them to be 4, 5, 6. No problem for me at all. Okay? So this is the general solution. Doctor, should I guess always the solution in this formula? No, actually, we are going to learn specific method to find the solution. Okay? And we will find this one. Depending on our method, which we are going to study, we will find this with those two constants. Okay? Now, I have the following question. Where does this differential equation come from? I mean, can I express this differential equation to describe some real life phenomena? Yes, actually, yes. Look to this phenomena. Now I have spring. I attached the mass for this spring, and I'm going to move the mass to the right. So move the mass to the right. The spring will stretch, and the mass also will go to the left, right. Okay, left and right. So now I have the motion. This motion, left and right, can be described using this differential equation depending on the second Newton's second law. Okay, so the displacement now, which is the motion for the mass, and the x here, which is the displacement, can be described using this differential equation. We are going to conclude this differential equation using Newton's second law, but maybe after 4 or 5 lectures. Okay, so only I need you now to understand that those differential equations, which we are going to study, not from the mind, those from real life problems. Also here I add this term. What I mean by this term, it's an external force. It's an external force. Okay. Now, for attendance, I need you to write your names in the chat. Okay. So write your names to know who attended the lecture today. Always, when I ask you write your name in the chat, you have to do that when I ask. Please don't write your name before I ask you to do that. Okay? So all of you, please write your name in chat to know who attended the lecture today. Always, I will ask the students to write their name to know who will attend from those who didn't attend the lecture. Now, the solution of differential equation with the interval of solution or the interval of the definition. Now, the solution of differential equation, it's a function such that if you plug in the differential equation, you will get an identity or something right. Okay? How to solve it, we are going to learn in the coming lectures. But in today's lecture, only I need to check if the given function is solution or no. So I will give you equation and I will give you function and I will ask you check that this function is solution. What should I do? I will plug in the differential equation. If I get something right, so yes, it's a solution. And you need to study the interval for the solution. Okay? Now let me give you a first example. In the first example, I have the function y, this function, look to the function y. I need to check that this y is solution for this differential equation. By the way, no one, I think, or it's very difficult to guess that the solution of this is given here. But after 6 lectures, we are going to learn simple method, very easy technique to solve this one, and we will get this function easily. But today, no, I need to check only. But here he wrote the word explicit solution. What do you mean by the word explicit? And in the coming slide, I have the word implicit solution. The explicit solution, that means the function is y equal something in terms of x, only x. So explicit solution, that means you have explicitly y in the left-hand side and all terms in the right-hand side with x and no y in the right-hand side. This is the explicit solution. And the implicit I'm going to explain in the coming slides. Now, how to find this solution? Today we can't know, maybe after 7 lectures. Now let me check with you that this function is really solution for the given differential equation. Yes, what I'm going to do now, I'm going to write using the PowerPoint pen, maybe it's to save it as a PDF for the students. Some students asked me from the first section to save my handwriting as a PDF. So here's the solution. Yeah. Here my y, and I need to plug in my y in the differential equation. My differential equation contains the first derivative. So for me, I'm going to find the first derivative. So here, first step is to find y prime. I'm sorry, actually, in the coming lectures, I'm going to ask the students by their names to answer my question. But maybe because it's first lecture today, so I need one of you to help. How to find the first derivative of y prime? Can anyone help, or should I choose one?
You can differentiate the first function.
Yeah, who is speaking?
Use
Yusuf. Yes, Yusuf. So now you will find the first derivative. Help me. Derivative of 5.
nothing plus
0. Yes, plus. Now the derivative of x times e. So you have a product. Do you remember the rule of a product? Yes, Yusuf.
I'm out of practice, I don't really know.
You forget the rule
I
of a
forgot
product.
the rule.
Yes, I will tell you. The rule of a product differentiation, you will find the differentiation of the first. So differentiation of x, it's 1. Multiply it by the second function, e to the negative x. Plus the first function as it is, x, times the differentiation of second. What is the differentiation of the exponential? Do you remember, Yusuf?
Negative e to the power of
Yes, Muhammad.
negative
So
x.
the differentiation of exponential function is only to differentiate the power, and differentiation of negative x, which is -1, times the same function, which is e to the negative x. Is it clear, the differentiation? So equal. 0 isn't necessary, and y, so e to the negative x. Here you have a plus and minus, minus x e to the negative x. Now let me find the second derivative. Professor, why should I find second derivative? Because I have here y double prime in my equation, and I'm going to plug in my equation. Now, I need also one to help to find y double prime, but now this is your function. So you need, you need to differentiate. You need to differentiate this. You need to differentiate this.
Negative e to the power of negative x.
Yeah, who is speaking now?
Muhammad
Who is
al-Gabili.
speaking? Yes, Muhammad. Start. So you need to find the differentiation of this.
Yes.
Yeah.
Negative e to
Negative
the power of
e.
negative x.
Great. Continue, please. The differentiation of this.
And then negative e to the power of negative x.
Look what I'm going to write. I'm going to leave the minus and open a bracket. The derivative of the first. I'm sorry, I'm going to do in details in this lecture and maybe in the 4-5 lectures, first or 4 or 5 lectures, everything in details, then I will be faster, okay? So derivative of x, it's 1, times the second function, e to the negative x, plus x times -1, e to the negative x. Okay, Muhammad?
Okay.
You can do it faster, but today I'm sorry to do everything in details. Yeah, let us simplify this. Help me, Muhammad. So here the minus will be inside. Okay, so here negative e to the negative x, and also negative e to the negative x. Here minus, and this minus will be plus x e to the negative x. Am I right?
Yes.
Yeah. Now, a negative e to the negative x and negative e to the negative x, it will be what?
Negative 2e power of negative
Great.
x.
Great, Muhammad. Negative 2e to the negative x plus x e to the negative x. After finding y prime and y double prime, what should I do? I
Put
found
them in the
this.
equation.
Yeah, plug in my equations. Let me call the equation star. So my equation star will give me, instead of y double prime, what I found here, negative 2e to the negative x plus x e to the negative x, okay, plus 2. Instead of y prime, I found this, which is e to the negative x minus x e to the negative x, plus the y, which is given here, 5 plus x e to the negative x equal 5. And I'm going to simplify this and check if I get something true or false, right or wrong, okay? So let me continue here. I'm going only to multiply this 2 inside. So it will be negative 2e to the negative x plus x e to the negative x plus 2e to the negative x minus 2x e to the negative x plus 5 plus x e to the negative x equal 5. Yeah. Now what I'm going to do, I'm going to cancel out some terms. Yes. This with this can be cancelled out. And what do you think about this and this? Those will be 2 and this -2. So those will be cancelled out. Am I right? So now this cancel out with this, and this with this with this. So the rest now, I have only 5. I have 5 equal 5. 5 equal 5 is right. So this function is solution for this differential equation. What do you think? Do you find it's clear? So do you have any question? Let us move to the implicit solution. Here I have the question. I have this relation. Can you see the relation here? And I need to check that this relation is an implicit solution for this differential equation. Just 1 minute. Professor, this is differential equation? What do you think about this? Can anyone of you tell me the form of this equation is what? What do you think about this equation? Is it differential equation? Yes. Repeat.
Differential form.
Differential form. You are right. So now the question is to check that this relation is an implicit solution for this differential equation. Just a minute, Professor. Why you said it is implicit? Why it isn't explicit? Implicit because you can't find y here in the left-hand side, and the right-hand side contain only x. So I call it implicit. Let us together do this problem here. Yeah. What should I do? So here's the solution. I'm going to differentiate the relation, this one. Should I use 1 or can anyone help? What do you think? Can anyone help? So I'm going to choose Basil. Basil here? Can you help Basil? Maybe is busy. Abdurrahman? Can you help Abdurrahman?
Yes, doctor.
Yes. So you need to differentiate this relation. Start, Abdurrahman. Here you have a product. Okay?
2xy.
2x, the differentiation of the first times the second one, great, plus
x squared y dash.
X squared y dash, great, plus
plus 4y to the power 3 y dash.
Great, nice, equal 0. The differentiation of constant. You need to try to go from this equation, which you asked me to write, into the given one. Yeah. What should I do, Abdurrahman? If you can help. So you need to find this one now.
The 2xy is already similar to the 2xy dx.
Yes, you are right. But here, where is the dx?
We have to differentiate again, I think.
No problem, Basil. If you differentiate again, so you will find y double prime. But one small question. Do you remember y prime is what? Y prime is what, Abdurrahman?
dy by dx.
dy by dx. So now I found dy and dx. So I can write instead of y prime, dy and dx, and I will get this one. Okay? So first of all, some students will ask me to take y prime as a common factor. So here 2xy plus bracket x squared plus 4y cubed. And instead of y prime, I'm going to write dy over dx. dy over dx equals 0. Now what should I do? What should I do?
Multiply by dx.
Multiply by dx. So times dx. So if you multiply by dx, so it will be 2xy dx plus x squared plus 4y cubed. And here you will cancel dx from the denominator. So you have dy equals and this is the given equation. Okay, I call this function implicit solution because you can't find y in the left and in your right hand side only x. But in the first example, which I did, I can find y alone in the left hand side and my right hand side contain only x. Okay, so this is the differential equation, and that means this relation is solution for this differential equation. Okay, any question here? Now let us together try to solve this equation, but I need some help. Let me use the blue maybe now. Can I write this equation in another formula? Actually, we need to guess also here. We need to guess. Can I write the equation y prime equal 2 over x, which mean y prime equal 2 times 1 over x? Don't forget that here you divided by x, which can't be 0. Okay? Now, can anyone of you guess the value of y? It's very easy, by the way.
2 ln x.
Great. Who is speaking?
محمد الجبالي.
Great, Muhammad. 2 ln x plus constant. Can I write a constant here? Because now if you differentiate this, you will get 2 over x. But now I need you to find the interval of this solution. That means you need to determine the domain of your solution. Can anyone of you tell me the x must be in which interval if you have ln?
Greater
than 0.
than or equal
Greater
1
than, greater or what?
or equal 1.
No.
Bigger than 0.
Yes, it must be greater than 0. You can find ln half, which is less than 1, but you can't find ln of 0 or ln of -1. Okay, so x greater than 0, so it must be from 0 into a plus infinity. This interval, we call it interval of definition or interval of the solution. That means after finding the solution, okay, or I give you the solution, find the domain of the given function. The domain, that means if you have ln, if you have square root, if you have a fraction, depending on your problem, okay? Now, family of solution. Let me introduce the concept of family of solution. Before solving this one, so now I need you to solve this differential equation. To simplify it, let us solve this equation. Y prime equals 0. Can anyone of you give me the solution of this equation? Solution of this equation?
Y equals c. Any constant.
Great. Y equals c. This is the solution. Great. Now, second equation. Y double prime equals 0. By the way, y equals c, I call it family of solution. Why? Because you can choose c to be 1, 5, 11, you are free. Now, this equation, y double prime equals 0. What do you think about this? Can anyone guess the solution of this?
y prime هتبقى equal constant or y هيبقى equal constant في x.
Yes, you are right. So y equal maybe c1x plus c2. Differentiate this twice, you will get 0. You are right. And I call this solution family of solution. Why I call it family of solution? Because it contains C1 and C2 source constant. You can choose them to be 1 and 5, -3 and 11. You are free. So family of solution. Let me go to this one. Can anyone of you guess the solution of this equation? So it's very easy for you. What do you think? Can anyone help? Yes, speak.
C1x squared plus C2x plus C3.
You are right. C1x squared plus C2x plus C3. Great, great. You are great students. So here also, if I differentiate this 3 times, I will get 0. Now I will call this one family of solution because my solution contains those constants. Okay, so starting from now, the word family of solution, that means your solution must contain some constants. By the way, always, 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 the number of the constants must be equal to the highest derivative. Notice here, highest derivative is 3, so 3 constants. Here, highest derivative 2, 2 constants. In the first example, 1 prime, so I have 1 constant. Okay? Let me go to the, any question? Do you have any question?
Yes, Doctor, shouldn't it be C1x squared over 2? Well, do we consider it in the C?
Yes, you are right.
Okay.
The divided 2 inside the constant. You are right. Yes, Muhammad, great. Other students, do you have any question? So let me introduce the definition of initial value problem now. Initial value problem, please, it's very, very important. And by the way, the word initial value problem, you will find it in exam 1, in exam 2, in the final exam. So you have to understand what I mean by initial value problem. Initial value problem, it means differential equation, any differential equation with some specific conditions. I will repeat. Initial value problems, that mean you have specific differential equation with specific initial conditions. And by solving initial value problem, I mean to solve the differential equation and use the given initial conditions to find the constants in your solution. So the solution of the initial value problem must contain no constant. Let me introduce this concept or explain it in the following example. Here I have this differential equation, and I have three conditions, okay? And he asked me now to solve this initial value problem. By the way, the notation for initial value problem, it is IVP, okay? Now, together, first step is, so here the solution to solve the initial value problem. First step is to solve the differential equation. Can anyone of you remind me the solution of this equation is what? Y3 primes equals 0. The solution is what?
C1x squared.
Okay, plus
C2x
plus
C3.
Solving the initial value problem, first step is to write the solution. How we found this solution? By guessing. Okay. Now, second step is to find C1, C2, C3. How to find those constants? By using the given initial conditions. Let me use the first initial condition. So first initial condition, y of 0 equal to. That will give me, don't forget, this 0 go for x and this 2 go for y. Let me plug in my solution star. So this is my star. Yeah, together now. Instead of y, focus please. Instead of y, you have 2 equal C1. Instead of x, you have 0, 0 squared, plus C2. Instead of x, this one also you have 0, plus C3. That will give you C3 equal to, I found the first constant. Now, second condition, y prime of 0 equals 0. But unfortunately, I don't have y prime. From where I will find y prime? I didn't have y prime. From where I can find y prime? Can anyone tell?
Y.
From
From
y.
y.
Differentiate this. So from this, you can find y prime equal. Differentiate will be 2 C1x plus C2. So this one is double star. So in double star, don't forget this for x and this for y prime. Okay? Yeah, I'm going to plug in double star. Y prime, it's 0 equal 2c1 times my x is 0 plus c2. That will give me my c2 is 0 also. Yeah, great. Now, third initial condition, y double prime of 0 equal -5. I don't have y double prime. I can't find it from here. Y double prime equal only 2c1. Yeah, so this 0 for x and this -5 for y double prime. In 3 stars, let me call this one 3 stars. In 3 stars, I'm going to plug in. Instead of y double prime, I have -5. Okay? Equal only 2c1. Only 2c1. No x here. So c1 is -5 divided 2. I found all my constants. After finding your constants, plug in your solution in one. So from those, all of those, I'm going to write in equation star, my y equal, instead of c1, you found -5/2, okay, x squared, plus your c2 is 0, plus your c3 is 2. So this is the solution of the initial value problem. I found the constants because I have initial conditions. So starting from now, if I ask you to solve initial value problem with specific initial conditions, after solving the equation, use those given initial conditions to determine the value of the constants, then plug in them in the solution. Okay? By the way, because the time is up, I have extra problem, but I'm going to do it in the coming lecture tomorrow. Let me tell you about the worksheet. So you have a worksheet. You have to submit on Blackboard. You'll find it on Blackboard. You have to submit it. Actually, I need to be 2:30, but one of your colleagues in the previous section asked me because they have lectures for other courses, so it will be due 6 o'clock. So every day you have, or every day, yes, you have worksheet due 6 o'clock. Okay, you have to submit it before 6 o'clock. And also, by the way, at 1 o'clock today, I can join again the Zoom meeting to do the worksheet together. So if you have any question about the lecture, or you need to discuss with me how to solve the worksheet, so we can meet at 1 o'clock. So after 15 minutes, if you need, and if you have any question. And if you need to do the worksheet by your own, you are free, or discuss with me at 1 o'clock. And I'm going to upload the lecture as a recorded video and as a PDF with my right handing in Blackboard, so you can do some revision. But I need to finish solving the worksheet with any one of you, then I will upload everything to Blackboard. Okay? So what do you think about the lecture? Is it easy or difficult?
زي الفل.
Yeah, it was good. Yeah.
So also to introduce myself and to let me know more about you, I'm going to send emails for each one of you. Maybe every 4 will be together to meet at night, maybe today or tomorrow. This meeting only to let me more about you and you know more about me, okay? For 5 minutes. But I should send you a specific time by email, and please try to attend this meeting only for introducing yourself and introduce myself, okay?
Okay, thank you, Doctor.
Yes, welcome all of you. If you don't have any question, I'm going to end the meeting, and at 1 o'clock I will go back. Okay, what do you think?
And thank you.
Thank you.
Welcome all of you.
Yeah, doctor, what is the access code for the Webassign software?
I think in the syllabus you will find everything, and you will find in the Blackboard also I attached two PDFs. Those one of them for the instruction how to use the coupon code, and the key also. You will find everything in the syllabus and two PDF in Blackboard. You will find all the details. Okay.
It doesn't have the access code يا دكتور.
لا موجود.
No, I
موجود.
added. Look. Today morning they sent me the coupon, the code. So today you will find it. I replaced the syllabus today.
اوكي يا دكتور.
Okay,
موجود
عمر?
فين طيب؟
In the syllabus you will find your syllabus in second page or third page. You will find how to enroll the Webassign. You will find the details here.
اوكي يا دكتور. Thank you.
Okay, عمر. Other students?
We have a question about Webassign also. We bought Webassign for Calculus 2 and 3. So do we need to buy it again for this
Yeah.
course?
Yeah, the differential equation
Yes.
is a new textbook, so you need it.
Okay.
Islam is speaking. Yes, you need to buy a new
Yes.
one. Yes, Islam.
Okay. Thank you.
Welcome, Islam. Other students? So goodbye, all of you. If you don't have any question, I'm going to end the meeting now. Bye, all of you.
Bye, though.
Bye.
Hello. Thank you.
Welcome, all of you.